In the previous video, we looked at this signal from your Turbo textbook, and it's from problem 4.17, and we figured out what the trigonometric Fourier series coefficients were. A0 is 0, the Bn terms are all 0 because it's an even function, and then we were able to calculate the An terms and found that they were 4 divided by pi n times sine of pi n over 4 for n odd. And in this particular video, we're going to be looking at examining the power in this signal and then the power in the various harmonics. So the total power in this signal, the total average power, is found most easily in the time domain, and we want to, the time average power, so that's why we're dividing by t, look over one period and square the signal and integrate it. So in this case we have a period of 8, so 1 over 8, and instead of going minus t over 2 to t over 2, we can take any period, so we'll go minus 1 to 9, I'm sorry, minus 1 to 7. So we integrate from minus 1 to 1, and the signal is 1 squared dt plus the other piece of the signal that's non-zero is from 3 to 5. And we have minus 1 squared dt. Those are pretty easy integrals. We end up with 2/8 plus 2/8, or a half. Okay, how do we find the power in the fundamentals? For each n, so power at each frequency is found in general an squared plus bn squared over 2, right? And if we had an a0 term, it would just be a0 squared. In this case, bn's are 0, so we just need to find an squared over 2 for each of these. So for n equals 1 an squared over 2 is the power. So just plug away, right? 4 over pi sine pi over 4 squared over 2 is going to be 0.41. We're only looking at odd n, so the first harmonic here is when n equals 3. 4 over 3 pi sine 3 pi over 4 squared over 2. In this case, we have 0.05. And we can keep going, so let's just do one more, n equals 5. So we have 4 over 5 pi sine 5 pi over 4 squared over 2. In this case, we get about 0.01 or 0.02. So we see in the fundamental in the first two harmonics, we have, summing this up, we have 0.48. So we have actually most of the power, right? The total power is a half, and in the fundamental and the first two harmonics we have 0.48, about 96% of that. So, and that's generally true in these, is that most of the power is in the first few frequencies.